Hello, this is Brother Cromer from the Math Department, and these videos will be talking about inference for two means paired data. And so here's the outline for these videos. First, I'll talk about an intro to matched pairs or paired data. Then I'll talk about hypothesis testing. Then I'll follow it up with confidence intervals, and then I'll wrap it up with checking requirements. Okay? So first of all, paired or dependent samples. So paired or dependent samples is where individuals in one sample are used to determine the units or individuals to be in the second sample. So an example that I have is, are sons taller than dads? So for instance, if we randomly choose a son, then that dad is already selected. So that second sample, for instance the dads, is dependent on how the first sample is selected. Okay, so here's an example down here. So if we choose these sons here, the dads are automatically selected. Okay, so either now, with paired data or matched pairs, either two units can be paired together or two observations can be paired with one unit. Okay, so here are some examples from the next slide. So for instance, either two units can be paired together. Here's an example where we have a husband and wife. So do married people have similar IQs? We can get the IQ from the husband as well as the wife, and we can pair those up. So if we take a sample and we sample a wife, then the husband's already selected. Okay? Or it's already predetermined the husband will be chosen because we chose his wife. Okay, now we could have matched pairs or dependent samples if two observations can be paired with one unit. I have two examples in this case in this slide, where if there's 6 students selected in our sample, and we want them to take a pretest and a post-test for a given class, well, these are two measurements, pretest and post-test for one unit, in this case of students. Okay. Another example is, which of two methods in Scouts is faster for starting fires? And I should add, without using a match. There's flint and steel, and there's battery and steel wool. So what we can do is that we can take these 6 Scouts, we can time them to see how fast they can start a fire in seconds in terms of flint and steel and battery and steel wool. So these are 3 examples of where it's either two units can be paired together, like this example where the husband and wife are paired together, or there's 2 measurements like pretest and post-test, or flint, steel, and battery, steel, and wool from one person. Okay, so now let's go through hypothesis testing. So now before I get into the steps of doing hypothesis testing, I want to compare here matched pair t-test and a one-sample t-test. Okay, they're actually very similar. This is the test statistic for one sample t, which was from the last lesson. We take our sample mean minus the null hypothesis divided by a standard deviation, which is, in this case, our sample standard deviation divided by the square root of n. Now, if we compare that to a matched pair or paired sample t-test, we take d bar, which is the mean of our differences. Okay, and so if we created a column of differences, we take father sites and son sites and get a difference. We can get d bar, which is the mean of our differences, okay, minus 0, and 0, we'll talk about this in just a sec. 0 is our null hypothesis, and I'll show you why in just a moment. And we also divide it by a standard deviation, where we take the standard deviation of the differences over the square root of our sample size. Okay, so now let's go through the 6 steps for doing a hypothesis test. Step 1 is state the null and alternative hypothesis, like we've done in the previous 2 types of hypothesis tests. The null hypothesis in this case is that the mean of the difference, that's what this means here, mu d means the mean of the true mean of the differences is equal to 0. Okay? The alternative hypothesis is that the true mean of the differences is less than, or it's greater than, or it's not equal to. It depends on the type of test that you plan on running. If you're doing a one-sided test, you either use this one or this one. If you're doing a two-sided test, you just want to see if there's a difference, you would use this one right here. Now, steps 2 through 4, we would use software, either Excel or Spss, to get our test statistic, degrees of freedom, and our p-value. After we get these results from steps 3 and 4, then these last 2 steps are the last 2 steps we've seen in the previous 2 hypothesis tests, whether we have one mean sigma known or unknown. It's the same type of deal with matched pairs. If we reject the null hypothesis, we reject the null hypothesis if the p-value is less than the level of significance. If not, we don't reject. And then we state our conclusions in layman's terms. If we reject the null, then we have sufficient evidence to say that, and then we state the alternative in plain English. If we don't reject the null, we have insufficient evidence to say that, and then we state the alternative in plain English. Okay, this is a blueprint of how you can write up your conclusions and going through an analysis. Okay, or going through a hypothesis test. You're into the last step. So let's go through an example of this. So do sons have different heights than dads? So a random sample of 13 sons and dads was taken. So we wanted to see if there was a difference. So step one, state the null and alternative hypothesis. The null is that the true meaning of the differences is equal to 0. This is why, if I go back to a couple of slides back, why the null hypothesis, we put 0 here because 0 is our null hypothesis. Okay, so the true mean of the differences is equal to 0. The alternative is that the true mean of the differences is not equal to 0. Okay, that's step number 1. Steps 2 through 4, we calculate the test statistic, the degrees of freedom, and the p-value. Now here are the numbers here are the results, but where you can get that is you can get that from your output in either Excel or SPSS. Now on the next slide I have an example from SPSS, which you'll see similar to it in Excel, where right here is we get our test statistic, it's under the T, degrees of freedom is under the DF, and then this is usually, at least in SPSS, it would be the p-value. Now it's only a p-value if it's a two-sided test. If it were a one-sided test, then you would take that number and divide it in half. But since the problem calls for it being a two-sided test, that number is, the p-value is 0.702. Okay. Parenthetically, you can get the mean of the differences up here and the standard deviation of the differences up here. Okay. So because our p-value is 0.702, it is greater than our level of significance, which is what we have up here. So we don't reject the null. Okay. So we have insufficient evidence to say that the heights of the fathers and sons are different. So we state the alternative, but since we didn't reject the null, we have insufficient evidence for the alternative to say that the mean of the differences, that the mean of the differences is not equal to 0, or that the heights, in this case, specifically the heights of the fathers and sons are different. So now what I want you to do is that if you go to the online wiki, here's an example of a man weight loss study, and if you click on this link, you can find the data. Okay, let me go to the man data. It's either, this is a SPSS data set or an Excel data set. So what I want you to do is I want you to stop the video, go through those 6 steps. Okay, now this is going to be a one-sided test. If you go to the problem, let me just pop this up here. If you go to the problem, it asks for, just look at it up here. Don't look at the answer down here, but look at it up here. 27 women participated in a 9-week weight loss study. During the study period, participants were provided a reduced calorie diet. Their weights were recorded at the beginning of the study and 9 weeks later. The difference of the weight is defined by post-study weights minus pre-study weights. The researcher expected that the mean difference in the weights would be negative. In other words, that women would tend to lose weight. Test that women's weight would decrease significantly with a level of significance equal to 0.05. So stop the video, go through these 6 steps with that data, and see what you come up with. Okay, so the 6 steps, the null and alternative hypothesis is that the null is that the true mean of the differences is equal to 0. The alternative is that the true mean of the differences is less than 0, because we're looking to see if the weights would decrease. Okay, given the parameters that we have up here, that the difference is the post-study weight minus the pre-study weight. We calculate our test statistic, degrees of freedom, and our p-value. Now what I have here is some SPSS output. Let me just go down a little bit. That shows you the results. Here's the test statistic, and you'll find this similarly in Excel. Here's your test statistic, here's your p-value, or your degrees of freedom, excuse me, and your p-value. Now this here, since it's a one-sided test, for you SPSS users, you have to take this number and divide it in half. But 0 divided by 2 is still 0, or close to 0. And so that p-value, going back to the slides here, that p-value is close to 0, and since our p-value is less than alpha, we reject the null, and so we have insufficient evidence to say that we have sufficient evidence to say that the weight significantly decreases with the weight program. So let me say that one more time. We have sufficient evidence to say that the weight significantly decreases the weight program. So I'll stop the video and I'll continue with confidence intervals and checking requirements in part 2.